Hey everyone, welcome to SingularityComputers Client Build 8, Part 7. The name of this build is Cytotoxic. I'm going to start this part of the build log by filling the graphics loop. Also in this video, I'm going to finish the wiring, install the lighting, continue work on the reinforcements for the loops, and start on the side panel modifications. I have the graphics loop set up and ready to be filled, and the coolant that I've decided on for this loop is Mayhem's X1 UV Clear Blue, to fit the theme and the effect that I'm going for, which is Serenkov radiation. I'll talk more about the coolant colors that I've decided on later in the build log. So I'm now filling the graphics loop, and while I'm doing this I'm going to talk about serial and parallel configurations. This connects with what I was talking about in the last part of the build log, which was single and multiple loops. A serial configuration is where you have one path for the fluid to flow through between your water cooling components. A parallel configuration is where you have multiple paths. Something that you really need to think about when building a loop in parallel is resistance. The fluid will always take the path of least resistance. So if you split your loop, for example, you have one loop for a CPU water block and one loop for a graphics water block. If the loop with the CPU water block has more resistance, then there's going to be less flow in that loop, more in the other, so the flow will be unbalanced. And the performance is obviously going to be worse in the loop with less flow, and you can seriously destroy performance like this in a parallel loop. The best thing to do to avoid this is to only build your loop in parallel through components that are the same or similar. For example, this graphics card water block configuration, 3 GTX 680 water blocks and an EKFC bridge triple parallel. So the flow is in parallel through these water blocks. What it means is 1/3 of the flow of the loop goes through each of these water blocks at the same time, whereas in series, a serial configuration, the entire flow of the loop would go through each of the water blocks one at a time. Now this is where it gets a little bit more complicated, and I'm not going to spend too much time talking about this. Something else that needs to be considered is that the more times you split a loop in parallel, the less flow is going to be going through each section. So with this graphics card water block configuration, it's 1/3 of the flow going through each loop, compared to the entire flow in a serial configuration. But because the loop has been split, the resistance has been decreased. Even if it's only in that section, this means that the overall flow of the loop has been increased. But does this make up for the decrease in flow due to the loop being split? It comes down to how the rest of your loop is configured and how powerful your pump configuration is. When it comes to which is going to be better, a serial or parallel configuration, there's really no straight answer, mainly because every loop is different. If you're really concerned with the performance of each, then the only thing I can suggest, other than what I've already talked about, is that you do some testing. So the loop is now full and circulating, and the color of the coolant currently is certainly not the color that it's going to end up as. It's this whitish color just because of all of the air, the micro bubbles that are in the loop. It will take 2 or 3 hours for the micro bubbles to come out of this loop, and a day or so for all of the air to come out. It took less than 5 minutes to fill this loop. Just like the other loop, it went very smoothly, no leaks or any problems. So that's it, both of the loops are now full. It's now time to move on to the completion of the wiring. So I have here the last of the wiring ready to be installed into the build. I've just finished plugging in the exhaust fan at the top of the build. I had to shorten the cable, and you can see I've plugged it in back there nice and clean and out of sight. I've also just finished plugging in the pump RPM sensor cable and temperature sensor cable for the graphics loop. I still need to do that for the CPU and motherboard loop, and I also still need to install the SATA data cables for the 2 SSDs, and also a wiring loom that I've made up for the lighting. So you can see the pump RPM sensor cable and temperature sensor cables there for the graphics loop plugged into the bottom of the motherboard. And I've just been through and cleaned up all of the PCIe wiring again. I've used mod smart clips and cable ties to hold them all in position. Otherwise they would have moved around in shipping, and there's now a far better gap for airflow. Just a quick look at the top of the build. I've talked about this in previous videos. The TJ11 has a USB 3 pass-through, which usually I think is a terrible idea, but because of the design of this case, the back I/O faces the top. It's far cleaner than running USB 3 cables inside of your build. They're big and bulky and they really mess up cable management. It's far better to hide it away at the top of the build under the top panel cover of the TJ11. Yes, it does take up an extra 2 USB 3 ports, but the ports on the back I/O panel are a little bit inaccessible in the TJ11 anyway, because you have to remove the top panel cover. So if you want more USB 3 ports, the best thing is to just get a USB 3 hub. Then you can run it out to a far more accessible position. Now looking around the back of the build, so I've added in those sensor cables. They run up the back of the blanking plate. Also a few more cable ties and cable management clips to clean things up. And these are the 2 sensor cables that I still need to connect. I've already cut them down to length. Now looking at the SATA data cables, these are actually Bitfinex Alchemy Black, and I've just sleeved straight over them with MDPC. And this is the wiring loom for the lighting. And this has all been made up custom. I had a couple of ways to go with the lighting. I could have used splitter PCBs. Basically, I want to run 5 lights, but I decided that custom cable was going to be a cleaner way of doing things. I'm actually going to mount this ModSmart 22mm blue ring vandal switch, which controls the lighting, down here on the back panel. I'm not one to put switches for things as unimportant as lighting in full view. I usually hide them away somewhere. And this is something I do often with custom wiring for lighting. I've used 3-pin fan headers because you just need a negative and a positive. So you just connect up 2 of the pins on the 3-pin fan headers and leave the other one free. I've used 18 gauge wiring right through. It's all sleeved in MDPC. And this is actually over 1 meter long because it needs to go from one end of the build to the other. Anyway, it's time to get all of this installed. I just booted the system for the first time and it booted successfully without any problems, so the system is up and running at last. And it's now time for the rest of the testing and validation. All of my client builds get an 8-hour leak test, then 72 hours of stability testing. Then if the client wants me to overclock the system, I do another 72 hours of stability testing, and this system is getting an overclock. But before I move on to that, I'm going to complete the lighting because currently less than half of the lighting is installed. But you can already see the effect that I'm going for with the coolant and the lighting. I'm getting a good UV glow. It's going to glow a whole lot brighter once the rest of the lighting is installed. I'm actually thinking of using blue lighting for the CPU and motherboard loop, just to create more of a contrast between the 2 loops. Anyway, it's now time to complete the lighting. I've now completed the lighting and also all of the wiring. I've ended up using 2 Lamptron UV LED flex lights for the graphics loop and a single Bitfinex Alchemy blue LED strip for the CPU and motherboard loop. I was going to use more UV LED flex lights, but it was just too much. It flooded the build with purple light. And this is something you need to watch out for when using UV light that you definitely need to avoid, because the whole point of using UV lighting in a build is that it only reflects off the UV reactive components, that way giving a glow-in-the-dark effect. And you can see I'm getting a good glow from the reservoir and acrylic tube, but the UV light is not reflecting off many of the other components. So what I'm doing with the lighting is drawing attention to the reservoirs and away from the center of the build. So both of the reservoirs are lit, the center of the build is in darkness, the graphics card water blocks and the EKFC bridge. The reason I'm drawing attention to the reservoirs is because they're major features of this build to fit the theme. A lot of the build is being designed around this, including the side panel, for example. I'm going to be redesigning the side panel so that the window is far bigger and there'll be a reservoir visible on either side. The center of the build is in darkness for a couple of reasons, one of them being the EKFC bridge, and I have talked about this previously. It's a component that I don't really like the aesthetics of and I didn't really want to use, but when I decided to use it, I knew that I was going to draw attention away from it, with the lighting in particular. The other reason is you should always have light and dark in a build. Never flood your build with light. Having contrast between light and dark will create a far better effect. So one LED strip for the CPU and motherboard loop was definitely enough. You can see the vandal switch down here on the back panel. Obviously I needed to cut a hole for it, but I'm happy with the position of it there. It's nicely hidden. Now for a look at how I've wired up the lighting and the rest of the wiring. The wiring loom for the lighting starts at the back of the build and goes all the way up to the top here. So this is the end of the wiring loom. There's 3 connections here. I've only used 2 of them because I've connected 2 Lamptron UV LED flex lights. All of the connectors are 3-pin fan headers, as I've mentioned. The wiring loom then goes across the top of the build here and down the back of the blanking plate. Now you might have noticed that one of the Lamptron flex lights has a few LEDs not working. I'm going to replace that one shortly. So it goes down the back of this blanking plate, then it curves around, goes between the 2 blanking plates and down through the mid plate with the rest of the wiring. And then I've curved it around here and it goes between the 480mm radiator and the power supply to the vandal switch. There's another cable coming back from the vandal switch which powers the entire wiring loom, and I've connected that to the BITS Power X station. So you can see the SATA data cables are now in position, and they go through the gap between the 2 blanking plates. They go down behind the mid-plate radiator and then connect to the motherboard. So now that the wiring is complete, you can see just how much wiring I have hidden behind the blanking plate. Without the blanking plate mod that I did, all of this wiring would be visible from the front of the build, and there's no way of cleaning it up or hiding it. It would be a complete mess if this blanking plate wasn't here. So it was an extremely important mod for this build. Okay, now back to the reinforcing for the water cooling loops. I've actually completed the reinforcing for the CPU and motherboard loop. I ended up spending over 4 hours just polishing this component, and it's come up with no imperfections whatsoever. I mentioned I was going to use organic shapes, and I think you can now see why. It needed to fit into an extremely tight position between the motherboard, pump and fan, and it fits in there nicely. It's not really visible here. It's certainly not eye-catching. You're not going to see it unless you go looking for it, and it does its job perfectly. I managed to do up the bolts very tightly, so it gives the loop a lot of strength. It's definitely not going to go anywhere. Now for the graphics loop, I've changed my plans a little bit, and because of this I need to start again. Instead of using 2 separate brackets, I'm going to use a single stronger one, and how I'm going to strengthen it is by bolting it to the top of the case. I'm going to use 10mm smoke plexi again, but in combination with that I'm going to use some UN brackets. So I'm now cutting out the acrylic, and what I'm working on here is a small piece of aluminium, and this is going to go at the top of the build. This is what I'm actually going to bolt the UN mounts to. I'm now sanding the acrylic. It requires an incredible amount of sanding to remove all of the imperfections from cutting it. So I go through a number of different grits of sandpaper and then move on to the polishing. I'm now using a Dremel to get the curves for the tubing, and with this a lot of it is guesswork because there's no real way of knowing how deep the curves need to be, or I mean I can measure where they need to be, but so what I need to keep doing is carving a bit out, going in and checking it with the build, to make sure, because the loops are actually slightly offset as well. They don't quite line up. So here I have all of the components, the acrylic, which I've now finished cutting out, and also most of the sanding, the aluminium plate and the UN brackets. I'm now masking up all of the components so that I can mark out all of the holes that need to be drilled. Anyway, I'm going to come back to the reinforcing again in the next part of the build log and complete it. I'm now going to move on to the modding of the side panels. The Silverstone Temjin TJ11 is definitely one of my favorite cases, but that doesn't mean there aren't things about it that I'd like to change. The ducts and 180mm fans are the worst thing about this case, and I think they're what turns a lot of people away. Having holes in the side panels just for the sake of airflow in a case that is going to be most likely used for water cooling anyway is definitely a terrible idea. So I knew that one of the things I was definitely going to do in this build was remove those ducts and those 180mm fans. They're also incredibly ugly. So I've done that. I've completely changed the midplate and a lot of the internal design. I've mounted a radiator on the midplate where the ducts used to be, but I'm still faced with the problem of the holes in the side panels. A couple of holes in these side panels may not seem like a big problem, but I can't just leave them there, and because of these holes I have to do a massive amount of work. As well as removing the holes, I'm going to change the side panel mesh, remove the bars from the lower ventilation, and I'm also going to expand the side panel window. So I've masked up the side panel, I've marked out where I'm going to make my cuts. I've also removed the side panel window, the side panel mesh, and the brackets that allow the side panel to be mounted onto the case. And I'm now making my cuts with a jigsaw. Now I have a lot of ideas for these side panels, and this is certainly one of my more drastic ideas, because basically what it involves is making entirely new side panels to go over the top of the old ones. But what it means is that I can cut the side panel window and lower ventilation holes to any shape and size that I want to, and when it's done it's going to look like the side panels were never touched. They're going to look factory. It's a lot of work, a lot of cutting and painting, but it's definitely going to be worth it. Now the mesh that I'm going to use, I was going to use a small perforation honeycomb mesh, but I wanted something that looks industrial, so I've decided on this mesh with large perforations, and this is going to allow plenty of ventilation, which this build really needs, because all of the airflow to 3 radiators is going through these side panels. That sums up this video. In the next part of the build log, I'm going to complete the build and go through all of the performance and temperature results, and that will be the final part of this build log. Thanks for watching. Please subscribe, like and favorite if you want to see more.